Hi, welcome to my platform, either the Facebook page or the YouTube channel for Sensor Academy. Make sure that you subscribe to this YouTube channel, and if you're watching this on my Facebook page, help me to share the video, leave a comment, and tag others that may find the same video very much beneficial, with that intention to prepare adequately for an exam. In today's tutorial, we're going to consider question 23, which is in mathematics paper 1, and the last question, which is under distance time graph. And we're going to use a 2017 paper 1 internal exam, and it says the diagram below shows the speed time graph of a 100-meter sprinter who accelerates uniformly for 3 seconds until he reaches a speed of 12 meters per second. He maintains the speed for 7 seconds and then uniformly retards for a further 4 seconds and comes to a stop. So whatever has been described in this diagram is what is shown, that is, or what is briefly written in this statement. So it means here it is that is the initial velocity, and under a distance time graph, we're going to find that on this y-axis, we're going to find the speed, rather the velocity given in meters per second, where we're going to have the initial and the final. And then that is in the x-axis, we're going to have that is the time. Calculate, and then on A, we have our question. Calculate the acceleration in the first 3 seconds. The acceleration is defined as the change in velocity over time taken. And as a result, when we talk about acceleration, we're talking about a line that images from 0 and going upwards. So from 0 up to this point, or from 0 up to 3, this is acceleration. Then from 3 up to 10, this is constant speed or constant velocity. Then from 10 to 14, this line is coming down, so this is uniform retardation. So calculate the acceleration during the first 3 seconds. So we're going to say on A, we're going to say acceleration equals final velocity minus initial velocity over time taken. So I'm going to say acceleration equals the final velocity was, that is 12 meters per second, minus the initial is 0 meters per second, then everything over the time taken is between 0 and 3. So between 0 and 3, so we're going to subtract, which is going to give us 3 seconds. So acceleration equals 12 minus 0, we're going to have that is a 12 meters per second over 3 seconds. We are now going to say, therefore, acceleration equals 3 here, 1. And we're now going to say 3 into 12, that is a 4. And then meters per second squared. And having done that, it means we're going to say acceleration equals to 4 meters per second squared. And then on B, it's saying retardation at the end of his race. So when we talk about retardation, this is negative acceleration, or just for a narration in simpler terms for a practice, you can just say A or R. So when we talk about retardation, we're talking about the final minus the initial over the time taken. So the retardation at the end of his race, we're trying to talk about between 10 and 14. So we're going to find that we're starting from, that is this point up to this point. So it means our initial was 0 meters per second minus, that is 12 meters per second over, and then here we're going to say 14 minus 10, this is going to give us 4 seconds. And retardation, rather A, we're going to say 0 minus 12, we're going to say negative 12 meters per second over, that is a 4 seconds. So we're going to say over 4 seconds. So acceleration equals, we just ignore the negative, so 4 into 12, we're going to have, that is 3 meters per second squared. So the retardation is going to be, that is 3 meters per second squared. I've ignored the negative because it is only implying direction. That's why. It is only implying direction. That's why. And then we're talking about, that is C, the distance he covered in the first 10 seconds. So if we're to talk about C, we're going to find that in the first 10 seconds, if this is our question, we're going to find that in the first 10 seconds, we are covering, that is, a triangle and a rectangle. It means we are coming from 0 up to 10. We're not including up to 14 to form a trapezium. So the formula for a trapezium won't work out. It's either we can be able to combine the two, or we can find the distance of this triangle and this rectangle. Mind you, distance under distance time graph is calculated in form of area. So we're now going to proceed. We're now going to say, on C, we're going to say distance equals, we're going to say A plus B. Let's say our A was the first triangle, so we're going to say distance equals to, now what was, that is our A. We're going to find that our A here was this, so let's say this is A, then this is B. So our base is between this and that, so 3 minus 0, which is Z, that is a 3. Then our height remains 12. For this one, it is 10 minus 3, so here there will be a 7. Then the height is still 12. So we proceed, where we're going to say half BH plus LB. And we're now going to say distance equals to, at this stage we say, that is half times the base is 3 times the height is 12, then plus, open bracket, to say 7 times 12. So I'm going to say distance equals to 2 here, 1, 2 there, 6. So 6 times 3, this is 18 meters plus 7 times 2. Remember, this is paper 1, that is 14. Remember 1, 7 times 1, 7 plus 1, 8. So we're going to say distance equals, this is going to give us 8 plus 4, which is going to give us, that is a 12. Remember 1 plus 8, 9, plus the one that remained, 10. So 102 meters. So this is the distance covered in the first 10 seconds, 102 meters. And having done that, it means we've answered a 2017 paper 1 exam using a velocity time graph or a distance time graph. And I hope, using the few of the concepts explained in this video, you can be able to relate them to the way some of the questions have been brought in preparation for the oncoming final GCE or internal exam. Ensure you share the video and leave a comment, tag others that may also find this video very much beneficial. Thank you so much for the support. Thank you so much for subscribing and following the page. This has been your tutor, Mr. Sensor. And I believe you're going to stay focused and stay determined in order to be on the same pace in preparation for the final exam. Remember, each and every of the day that you practice, you are able to attain self-reliance and self-dependence. Stay rooted and focus on the possible and the positive if you are an internal candidate awaiting for an exam. Till in the next video, for now, it's a very goodbye.